Students, so we have discussed about how to find the mean, variance and standard deviation of a given data, and we will discuss some more questions based on this one, because this is the most important thing. And you know that standard deviation, or when you have to find the standard deviation, you should know the mean values also. Now take down the question. Calculate the mean, calculate mean, variance and standard deviation of the following data. Xi values are given: 4, 8, 11, 17, 20, 24, 32. The frequencies are given: 3, 5, 9, 5, 4, 3, 1. Now here you can observe in the data the Xi values and the frequencies are given. So how to find the mean? In that case, mean is calculated using the formula sigma Fi Xi divided by sigma Fi. And the variance is calculated. This is a variance. Variance is calculated using the formula sigma Fi into Xi minus X bar the whole squared divided by sigma Fi. And standard deviation sigma is equal to square root of the variance. So first of all, you will write the formula for all the notations we have to find out. That is, you have to find the mean, variance and standard deviation. Mean, variance and standard deviation. So how do you start with? Now, when the frequencies are given, find out the total sum: 8, 17, 22, 26, 29, plus 1, 30. Now, next column will be Fi into Xi. Fi into Xi. 12, 40, 99, 7 5 is 35, 85, 80, 72 and 32. Sigma Fi Xi 11, 16, 20, 4, 5, 6, 7, 16, 24, 32, 39, 420. So X bar is equal to 420 divided by 30. X bar is equal to 14. Here you should know that class intervals are not given, only the values are given. Xi values are given. So 14. So next column will be Xi minus X bar. Xi minus X bar. 14 minus 4 minus 14 minus 10. 8 minus 14 minus 6. 11 minus 14 minus 3. 17 minus 14, 3. 20 minus 14, 6. 24 minus 14, 10. 32 minus 14 is equal to 18. Next column will be, you are finding out the variance. So next column will be Xi minus X bar the whole squared. 100, 36, 9, 9, 36, 100, 324. So when you add all together, Xi minus X bar the whole square. Next column, before adding, you have to find out sigma Fi into Xi minus X bar the whole square. So next column will be Fi into Xi minus X bar the whole square. So frequency 3 into 100, 300, 5, 180, 9 into 9, 81. 5 into 9, 45. 4 into 36. So 24 carry 2. 144. 3 into 100, 300. 1 into 324, 324. So when you look at the formula, it is sigma fi into xi minus x bar the whole square. And when you add, it comes up to 1374. So what is the variance is equal to? It is equal to 1374 divided by sigma fi. Sigma fi is equal to 30 and the answer is equal to 45.8. Use your calculator. 45.8. Now you have to get the standard deviation. Standard deviation is equal to root of variance. Is equal to root of 45.8 and that is approximately equal to 6.77 is the answer. So you should note that when xi values are given and when the frequencies are given, what is the mean, variance and standard deviation? Mean is calculated using the formula sigma fi xi divided by sigma fi. Sigma fi xi, I hope you have understood, frequency into the xi values, sum divided by sigma fi. Next is the variance. Variance is calculated using the formula sigma fi into xi minus x bar the whole square divided by sigma fi. So find out xi minus x bar. Some values will be positive, some values will be negative, some can be even equal to 0. And when you square it, all values will become positive. Xi minus x bar the whole square. Next column will be fi into xi minus x bar the whole square. Find the total sum. And the total sum divided by sigma fi gives you the variance, and square root of the variance gives you the standard deviation. Standard deviation is always taken as a positive value. So is this clear to you? Yes. Okay. So this part is clear to you. Now next we will calculate the mean, variance and standard deviation when class intervals are given. You can use the same formula or you can use the formula which I have given you as, what is the formula to find out the variance is equal to x squared by n squared into n into sigma fi di squared minus sigma fi di the whole squared. While using this formula, the one which I have said right now, while using that formula, you can see that the calculation values, the calculated values will become very small. So it makes the calculation quite easy. Or you can use the same formula as right now just used. So we will do one based when class intervals are given. We will do two questions, one based on the lengthy formula and the other one based on this formula which we have used just now. Okay, take down the question. Calculate the mean, variance and standard deviation for the following data. Class interval 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. And the frequency values are 5, 8, 15, 16 and 6. Now, calculate the mean, variance and standard deviation. I am using the shortcut formula. Mean x bar is equal to a plus sigma fi di into h divided by sigma fi, where a is the assumed mean. So since I am finding out di over here, I will use the formula for variance as h squared by n squared into n into sigma fi di squared minus sigma fi di the whole squared. And of course you know standard deviation is equal to square root of the variance. So first thing is you have to write the formula, only then you can construct the columns you require. Now what about the formula for mean? You require the assumed mean. Assumed mean means you have to find the mid values of the classes, xi values, 0 plus 10. How do you calculate the mid value? Lower limit plus upper limit divided by 2. That is 0 plus 10. 10 divided by 2, 5. This will be 15, 25, 35 and 45. 45. 1, 2, 3, 4, 5 values are there. So assumed mean you can take it as 25. The middle value among the xi is taken as the assumed mean. Now next column you can create di. Di is equal to xi minus a divided by h. So this will be equal to, corresponding to this one, it will be equal to 0. 25 minus 25, 0. Divided by 10 is equal to 0. Next one, 15 minus 25 minus 10. Minus 10 by 10 minus 1. 5 minus 25 minus 20 minus 2. 35 minus 25, 10. 10 by 10, 1. 45 minus 25, 20. 20 by 10, it is equal to 2, di. Now next column, it will be fi into di. Fi into di. That is 5 into minus 2 minus 10. 8 into minus 1 minus 8. 15 into 0, 0. 16 into 1, 16. 6 into 2 is equal to 12. When you add, this is equal to 28 and this is equal to minus 18. So the total sum is equal to 10. Sigma fi di. So this will be equal to assumed mean. Assumed mean is 25 plus sigma fi di. Sigma fi di is 10 into h is a class width. Class width is equal to 10 divided by sigma fi. Sigma fi 13, 13, 28, 28, 44 plus 6 is equal to 50. So this is 25 plus 2 is equal to 27. So mean is equal to 27. Now we come to variance. Sigma h squared by n squared. H you know 10, n squared 50 squared, n you know sigma fi di squared. Sigma fi di squared means next column you have to find out di squared. Di squared is equal to 4, 1, 0, 1, 4. And next column will be sigma fi di squared. So that will be fi into di squared. Fi into di squared. Fi 5 into 4, 20. 8 into 1, 8. 15 into 0, 0. 16 into 1, 16. 6 into 4 is equal to 24. Add together 8 plus 6. 10 plus 8, 18. 2, 3, 4, 5, 6, 68. Next you require sigma fi di the whole square. So what is sigma fi di? Sigma fi di is equal to, you have already found out, it is equal to 10. So sigma fi di the whole squared is equal to 10 squared is equal to 100. So substitute here, it is equal to h squared 10 squared by n squared 50 squared into n 50 into sigma fi di squared. sigma fi di squared is equal to 68 minus sigma fi di, it is equal to 100 the whole squared. So when you calculate, it becomes it becomes 3300 divided by 25 is equal to 132. And so sigma is equal to square root of 132 is equal to 11.489. This is how you calculate the mean, variance and standard deviation when class intervals are given. One thing you have to see that the class interval should be continuous. If not continuous, you have to make it continuous by subtracting 0.5 from the lower limit and adding 0.5 to the upper limit so that the class intervals becomes continuous. So mean is equal to a plus sigma fi di into h divided by sigma fi, and variance is equal to h squared by n squared into n into sigma fi di squared minus sigma fi di the whole squared, and standard deviation is equal to square root of variance. So ai, assumed mean, you have found out, and this is how you do the standard deviation, mean and variance when class intervals are given. Okay. Now, I hope you have completed everything. One more question we will do. Find out the mean and variance. Xi values are given 92, 93, 97, 98, 102, 104, 109, and the frequencies are given 3, 2, 3, 2, 6, 3 and 3. Now, here class intervals are not given, only the xi values and frequencies are given. So, how do you calculate mean? Mean is equal to sigma fi xi divided by sigma fi. So, first we will find out sigma fi. 5, 10, 10 plus 6, 16, 16 plus 3, 19 plus 3 is equal to 22. Next column will be fi into xi. 6, 27, 2 3s are 6, 2 9s are 18, 21, 2 27, 28, 29, so 16, 18 and 1 19, 6 2s are 12, carry 1, 6, 3 4s are 12, carry 1, 3 1s are 3, so 27 to 327. And the sigma sum is equal to 2200. So what is x bar is equal to? Sigma fi xi 2200 divided by 22 is equal to 100. This is the mean. Now variance. Variance is equal to, what is the formula you use? Sigma fi into xi minus x bar the whole squared divided by sigma fi. So next column you will find out xi minus x bar. Xi minus x bar is minus 8, minus 7, minus 3, minus 2, 2, 4 and 9. Next one will be xi minus x bar the whole squared. Look into the formula. Xi minus x bar the whole squared. 64, 49, 9, 4, 4, 16, 81. Next one will be fi into xi minus x bar the whole squared. So frequency into 3 4s are 2 carry 1, 18, 1 19, 98, 27, 8, 6 4s are 24, 48, 243. Sigma fi into xi minus x bar the whole squared. It comes up to 640. So what is the variance is equal to 640 divided by 22. Variance is equal to 29.09. 29.09. Next one. Next subheading, coefficient of variation. I'll write down. Coefficient of variation. Coefficient of variation for a particular data is given by sigma by x bar into 100. Sigma by x bar into 100. Take down data with less value of standard deviation. Less value of standard deviation is said to be more consistent. Data with less value of standard deviation is said to be more consistent. Now, let us calculate coefficient of variation. coefficient, I'll write coefficient of variation as CV. Coefficient of variation of two distributions are 60 and 70. 60 and 70. Their standard deviations are 21 and 16. What are their arithmetic mean? What are their arithmetic mean? So this is an information. Data with less value of standard deviation is said to be more consistent. Coefficient of variation of two distributions are 60 and 70. So CV of 1 is equal to 60, and that is equal to sigma 1 by x1 bar into 100, and the other one is 70. 70 is equal to sigma 2 by x2 bar into 100. Their standard deviations are 16 and 21. That is 60 is equal to 21 by x1 bar into 100, or cross multiplying, x1 bar is equal to 21 by 60 into 100. 2 3 times, 2 5 times, 3 7s are 21, 7 5s are 35. So mean for the first data is equal to 35. In the second case, 70 is equal to, standard deviations are 16 by x2 bar into 100. Cross multiplying, x2 bar is equal to 16 by 70 into 100. Is equal to 160 divided by 7. You will get approximately equal to 22.86. So this is how you find out. When the mean is given, you can find out the standard deviation, or when the standard deviation is given, you can find out the mean. Clear? Okay, I hope you have copied down the question and answer. So what is coefficient of variation is equal to? Coefficient of variation is equal to standard deviation divided by arithmetic mean into 100. And the data with less value of standard deviation is said to be more consistent, or data with more value of standard deviation is said to be more variable. Consistent, opposite of consistent is more variable. Data with more value of standard deviation is said to be more variable. Less value of standard deviation will be more consistent. Next one. Next one. It is about the height and weight. The data is given as height, weight, mean 162.6, weight 52.36, variance 127.69, 23.1361. So two data are given, the height and weight. The mean height is equal to 162.6 and the corresponding weight is 52.36. the variance is of height is equal to 127.69, and for the weight the variance is equal to 23.1361. Can we say that weight shows greater variation than heights? Can we show that weight shows greater variation than heights? In that case, variation when it comes up to, you have to use the formula for coefficient of variation of weight. Coefficient of variation for height, let us take for height, is equal to sigma 1 by x1 bar into 100. For height, the mean is equal to sigma 1 is equal to 127.69 divided by 162.6 into 100. Is equal to 6.95, and coefficient of variation for weight is equal to sigma 2 by x2 bar into 100 is equal to sigma 2. Here it is the variance is given, so standard deviation, root of weight 23.1361 divided by x2 bar 52.36 into 100 is equal to 9.19. You may be thinking why I found out this value here and here, because here it is a standard deviation. Sigma 1 and sigma 2 are the standard deviations. Given are the variances. Given are the variances. So you have to find out the standard deviation. Coefficient of weight is greater than coefficient of variation for height. So weight shows greater variation. Weight shows greater variations. So what are the concepts we studied in this class? We studied two things: measures of central tendency and measures of dispersion. Measures of central tendency, there are three, but we consider into consideration only two of them. That is the arithmetic mean and the median. Arithmetic mean and the median, when a grouped data is given and when an ungrouped data is given. Next one, we found out the median. Median is a middle value when the items are arranged in the order of magnitude. When the order of magnitude, median is the middlemost item. And when class intervals are given, how to find out the mean? it is a plus sigma fi di into h divided by sigma fi, where a is the assumed mean, fi's are the frequencies, di is the deviation, xi minus a divided by h, and h is the class width. And whenever you do a question in statistics, make sure that the class intervals are of the continuous type. If not continuous, make it as continuous type. And median. Median is the middlemost item when the items are arranged in the order of magnitude. Order of magnitude, that is either arranged in the increasing order or in the decreasing order, and find the middlemost value. When the class intervals are given, it is L plus n by 2 minus C into h divided by f, where L is the lower limit of the median class, f is the frequency of the median class, h is the class width of the median class. So everything is based on the median class. So what is median class? Median class is that class whose cumulative frequency is just greater than or equal to n by 2, capital N by 2. Capital N by 2 means sum of the frequencies divided by 2. Cumulative frequency, I hope you remember how to get the cumulative frequencies. And after that, measures of central tendency, we come to measures of dispersion, that is range. It is the simplest measure of dispersion. It is maximum value minus the minimum value. Then we have found out the variance and the standard deviation when class intervals are given, when class intervals are not given. And based on mean and standard deviation, among measures of central tendency, mean is considered to be the best measure of central tendency. Similarly, among measures of dispersion, standard deviation is considered to be the best measure of dispersion. And when you consider mean, variance and standard deviation, there is a relationship between variance and standard deviation. Variance is equal to square of the standard deviation, or standard deviation is equal to square root of variance. From that we come to the variability, coefficient of variation. Coefficient of variation is equal to standard deviation divided by mean into 100. And weight shows greater variation. Here coefficient of variation of weight is greater than coefficient of variation of height. So weight shows more variation. Now take down the next note. These notes can come as fill in the blanks for exam. From the point of view of exam, you may get some fill in the blanks or multiple choice 1 mark questions you can get. So take down the note. If each of the observations x1, x2, x3, etc., xn is increased by a, where a is a negative or positive number, variance remains unchanged. Variance remains unchanged if each of the observations is increased by a, that is increased or decreased by a. Suppose the original values are equal to x1, x2, etc., xn. If it is increased by a means x1 plus a, x2 plus a, etc., xn plus a. Or decreased, increased or decreased, x1 minus a, x2 minus a, etc., xn minus a. where A is a positive number or a negative number. In these two cases, variance remains unchanged. Variance remains unchanged. You can try with a small examples. Next one. If each observation is multiplied by a constant k, multiplied by a constant k, the variance gets multiplied by by k squared of the original variance. That means if you have some observations x1, x2, etc., xn, and you are multiplying each of the observations by the constant k, and here let us say the variance is equal to sigma squared. In this case, let the variance be equal to sigma squared. Now you are multiplying each of the observations by the constant k. K into x1, k into x2, etc., k into xn. Then the theorem states that in the new case, the variance becomes k squared into sigma squared. K squared into sigma squared. So these are the two fill in the blanks you can get. You can try with some small examples. I hope everything is clear to you. With this we complete the chapter statistics, and we will move on to the next chapter, that is the conic section for today. So complete the exercise in the textbook, and this is all for statistics. Thank you.